So my name is Greg Salamo. I am a professor here at the University of Arkansas. I'm in the physics department. When you reduce the size of a material like a piece of gold to a smaller and smaller and smaller size, we observe that it changes color, that it changes hardness, that basically all of its properties change as a function of size and shape as well. So as a result, if you look at anything in the periodic table, we have for a long time thought that these were the materials we had to work with in making new things. This turns out to not be true, simply because we can take any element in the table and change its size and get different properties. So all of a sudden we have this situation where we have an opportunity to discover properties of new materials. But of course what that means is, just like all of the effort that went into developing the periodic table, we have to make a similar kind of effort to understand how size and shape affect the properties of a material. A lot of the inspiration in this project for changing the surface of material comes from observing what nature is already doing. Nature already makes materials that can change color from one color to another. This is based on the nanoscale behavior of materials, where we're changing the separation between nanoparticles or the shape of nanoparticles, and that results in a change in the properties of that material. We want to make surfaces, for example, that might affect the growth of cells. We want to make surfaces that might affect or decrease friction. We want to make surfaces that, for example, might change color if we apply an electric field, or change hardness if we apply an electric field, or change the reflectivity of the material, make it transparent with an electric field. All kinds of possibilities. There's nothing that one should really rule out as possible. And that's why this area of science is so exciting. It's because it's currently a frontier.